Let's go the other way. Let's start with the name and write the symbol. This is just as easy as it was before. Dihydrogen monoxide. There we have dihydrogen monoxide. Di, we know it means two. Mono means one. Hydrogen, its symbol is H. And oxygen, its symbol is O. So this is easy to name. I have H. How many of them do I have? I have two. And I have oxygen. How many do I have? I have one. So I have dihydrogen monoxide. It's just a fancy way to say water, H2O. Let's do another. Dinitrogen trioxide. Di, looking at my chart, I know means two. Nitrogen, symbol is N. Tri means three. Oxide, I know my symbol is O for oxygen. So I'm going to have N. How many of them? Two. And O. How many of them? Three. N2O3. Perfect name. Let's come to my next one. Carbon disulfide. Now I know there's no prefix in front of the carbon, so I know that there's just one of them. So I'm going to write one above it. There's no prefix, so I assume that it's mono. Disulfide, di means two. And sulfide, if it was sulfur, remember it changed its last name, its symbol is S. Carbon symbol is C. So I'm going to write C. How many of them do I have? One. Sulfur, its symbol is S. How many do I have? The prefix is di, so I have two. So its symbol is C1S2. That's how we name covalent compounds. Let's go on. Last thing you need to know for the test is drawing Lewis structures. So let's look at two examples. You can do these two examples, you're going to do great on the test. First one is LiO2. So I have to ask myself, Li and O. Where is Li? Where is it found on the periodic table? It's on the left-hand side. It's a metal. O, it's over on the right-hand side. It is a non-metal. Now remember, if I have a metal and a non-metal, what do I have? Ionic or covalent? I definitely have an ionic compound. So let's look at my next example. C and O2. C is a non-metal, and O is a non-metal. So I have two non-metals. So if I have two non-metals, I have a covalent compound. So next step, draw the Lewis structures. I have two Li's and one O. So if I draw two Li's, there's one Li. Here's another Li. And I know that both of those Li's, since they're in group 1, have one valence electron. So I'm going to put one valence electron on the Li and one valence electron on this Li. I'm also going to draw O. O has 6 valence electrons because it's in group 6. So 1, 2, 3, 4, 5, 6. 6 valence electrons. Let's do the same thing down here for my nonmetal. I have carbon. I have one of them, so I'm going to write a C. And I know that it has 4 valence electrons. It's in group 4. So 1, 2, 3, 4. I only have one of those carbons. And I have 2 oxygens. So I'm going to draw my 2 oxygens. One oxygen there and one oxygen here. And I know that each oxygen, just like I did before, have 6 valence electrons. 1, 2, 3, 4, 5, 6. And this oxygen also has 6. 1, 2, 3, 4, 5, 6. Now I just have to figure out how they're going to come together. So let's start with the Li2O. Now I know that this Li wants to give its electron away. And so this Li also wants to give it away. They're both from the metal kingdom. So this Li is going to give his electron away to the oxygen. Oh, there's a spot that it can go right there. This Li is going to give his electron away to this spot right here. And so when they give them away, oxygen's getting 2 electrons. So think about my book example. It gets 2 electrons. It's going to get a -2 charge. That's a very bad 2. A -2 charge. And both of these, since they're giving their electrons away, they're going to feel happy to get rid of the electrons. They're going to get a +1 charge. And this one's also going to get that +1 charge. So when I draw my final example, the way I'm going to draw it is I'm going to have an O in the middle, and it's going to have an Li bonded, whoa, that's really bad, Li bonded right there, and the other Li is going to come down here, Li. Sorry that that's so bad. And then I'm just going to put my electrons. Oxygen, it had its same electrons, so it had 1, 2, 3, 4, 5, 6. And lithium, it brought its electrons, it transferred them, so 5, 6. And I want to make sure I label the charges on here. I'm going to switch back to my gray color. Actually, I might even change to a different color. My oxygen, since it got these 2 electrons from the Li, it becomes -2. And the Li, since they gave away their electrons, they become +1. This Li becomes +1. And I always have to make sure that I write the charges whenever I'm dealing with something that is ionic. I have to write the charges. Now let's do the covalent one, and then you'll know everything you need to do for the test. This column, it says structural formula if covalent. I knew that this Li2O was ionic, so I'm just going to put a big X through that column because I don't have to do it this time. Now, covalent, they like to share their electrons, and they all like to reach the magic number of 8 because that's how many they like to have. So my carbon has 4, and both of my oxygens have 6. So the question you have to ask yourself, and sometimes you just have to play around with this a little bit, is how can I combine these 3 elements so that they all have 8 electrons? And so what you can think to yourself is, oxygen has 6, carbon has 4. So if oxygen gets these 2 electrons from the carbon, it's going to be happy. And if the other oxygen gets these 2 electrons, it's going to be happy. So the way I would draw it is this. Carbon with 1, 2, 3, 4 electrons. And then the oxygens using a different color just to keep things separated. I'll use blue. And the oxygens are going to have 6 electrons with them. They're going to share 2 with the carbons, 1, 2, and they're going to have their other ones, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. So now both the carbon and the oxygen are happy. They're sharing all of their electrons. And I can draw a circle around the oxygen. It has 1, 2, 3, 4, 5, 6, 7, 8. 2 that it got from the carbon. It's happy. This oxygen has 1, 2, 3, 4, 5, 6, 7, 8. And the carbon has 8, so it is also happy. And I can draw my structural formula just by changing the bonds into lines. Carbon, double bonded, since there's 2 pairs of electrons to oxygen. And this carbon double bonded to this oxygen, since there's 2 pairs of electrons. And I only have to do that because it's covalent. I wouldn't do it if it's ionic. And since it's not ionic, I don't have to worry about writing charges because they're all happy. And that is what you need to know for the test. I'll probably put together a Word document that has a few other things on it. I'm sorry this video is so long, but if you watch and know this video, you're going to do great on the test. See you later.